Hello everyone and welcome to this video. In this video I will be talking about the thinking distance and braking distance, their factors that affect it, and the terminal velocity. Okay, let's start with this. So here you can see that the car is traveling with a constant velocity. Yes, and while it is traveling it sees a hazard. Wow, that's great. It sees a hazard. And when you see a hazard, you definitely try to overcome the situation. In this case, the driver sees a dog and he wants to save it. So he starts thinking. And before applying the brakes, it takes some time to apply the brakes, right? So he finally applies the brakes, and the distance while the driver took to think is known as the thinking distance, and the time which he has spent before applying the brakes is known as the reaction time, or simply it is the thinking time. And usually cars at highways, they move at a very high speed. We will consider that it is moving at a greater speed. So if it applies the brakes, it will skid. So it will skid like this. And you can see when the brakes are applied and before the car stops, it covers a minimum distance, right? It covers a minimum distance. That distance is known as the braking distance, and the time which the driver has spent is known as the braking time. Now we will consider the factors like the driver when he sees the dog and before he applies the brakes. The time is known as the reaction time. What can be the factors that affect it? So the number one is, you can see the driver is drunk. If the driver is drunk, he's not in his proper mental condition and it will take more time for him to apply the brakes. Number two is poor eyesight, and number three is illness. These are the factors that affect the reaction time of the driver. Now the brakes are applied, and the factors that will affect the braking distance and braking time, that is not the case of driver anymore. It is now the conditions, other conditions other than the driver, that will affect the braking distance and braking time. Number one is the poor condition of the brakes. So if the brakes are not in good condition, they won't be able to grip the tires. As a result, the braking distance will increase. The second point is the poor condition of tires. If the tires are not good, they won't be able to grip the road and stop the car. So the condition of the tires are also very important. And the speed of the car, like before applying the brakes, if the car is traveling at a greater speed, then after the brakes are applied, it will skid more. So the speed of the car is also a crucial factor. Now let's come to the graph. This is the graph that is most commonly asked in IGCSE exams. So here you can see the car is initially moving at 10 meters per second. So basically at this point the car sees the hazard. Then after traveling, and in this case we will assume that the car is moving at a constant speed or constant velocity. So it is moving, and at this point, when 0.5 seconds has elapsed, the driver has finally applied the brakes, and as you have applied the brakes, the velocity will start to decrease. It decreases and straight comes to rest, means 0 meter per second. Finally the car stops. Then after you see the hazard and before the brakes are applied, this is your thinking time that you have calculated from the graph, which is 0.5 minus 0 is 0.5 seconds, thinking time or reaction time. Then what happens is you apply the brakes, and before the car stops, this is your braking time. You need to subtract these two values, which is 1.5 seconds minus 0.5 seconds is equal to 1 second. Then you have thinking distance. How you can calculate it? As we all know that the area under the graph of velocity time graph gives us the distance. If you want to calculate the thinking distance, you need to find this area up to which the thinking time 0.5 seconds. You need to find this area. And if you want to find the braking distance, you need to consider this area and calculate this. If you calculate this area, you will get the thinking distance. If you calculate this area, you will get the braking distance. If you add them up, you will get the stopping distance, the total stopping distance. Okay, so now we are going to discuss about terminal velocity. And before we proceed into terminal velocity, we need to learn uh, two factors that affect the air resistance. For IGCSE, we will be learning two factors only: the speed of the object and the surface area of the object. These are the two factors that affect the air resistance. There are also several more factors, but that is not included in case of IGCSE. Okay, so let's start. Here you can see a plane, and here we have a person whose weight is 800 Newton. Okay, so what will happen? The person will jump. So in this case, the person jumps, and initially the only force acting on this person is the weight. As he speeds up, because he's falling under gravity, he will definitely speed up. Air resistance will start to increase, right? Air resistance will increase because you can see here that one of the factors that air resistance depends on is the speed of the object. If the speed of this person increases, the air resistance will also increase. Great. So you can see that the weight is 800 Newton and the air resistance above is 200 Newton. So we have a resultant force of 600 Newton in the downward directions. Still we have a resultant force. So what will happen is, due to this resultant force of 600 Newton, it will have an acceleration in the downward direction. It is falling, so it will definitely have an acceleration. And acceleration means that the speed of the object will increase. Since speed increases, the air resistance will also increase, right? So the skydiver accelerates, so it will speed up, the speed increases, and when the speed increases, the air resistance will also increase. So at a certain point, you can see that air resistance has increased and it became equal to the weight. So what I've written here is air resistance increases and it becomes equal to the weight. Air resistance equal weight, and you can see, according to Newton's first law, when all the forces acting on an object are balanced, the object will fall with a constant velocity, right? In this case, the person will fall with a constant velocity, and in this case, it is known as the terminal velocity. Okay? So, the person is trained in such a way that when he knows that he is falling at a terminal velocity, he will open his parachute. Okay, so what is the difference? Before opening the parachute, he had a small surface area, and the parachute is usually so big that, so that the surface area is much more bigger. So as you can see, this huge surface area of the parachute increases the air resistance. Surface area increases, so the air resistance will increase. So it has increased to such a point that it becomes more than the weight. So you can see we have a resultant force of 200 Newton in the upward direction. So the skydiver will slow down and reach second terminal velocity. So let's check out the graph. It is the graph for this person. Before opening the parachute, the velocity increases, and you can see the gradient decreases, so definitely the acceleration decreases. And when he realizes that he has reached a constant velocity, he opens his parachute, right? And after opening the parachute, the velocity decreases. It decreases and it has reached a new terminal velocity. That's great. But you can notice one thing, that the first terminal velocity is more and the new terminal velocity is less. And there is another question that can come in the exam, is why this velocity is less? It is due to this parachute. Because when you open the parachute, you decrease your speed. As a result, the new terminal velocity has decreased. Well, that was it. I hope you guys liked the video, and thank you.